Okay, so here we are on the Instructable site, and what we want to try and do is see if we can modify the code for this project to work with the hardware that I created for my Raspberry Pi class on Skillshare. So let's just go through this. Scroll down here, and one of the first things that it says we'll need to do is we'll need to create a Plotly account. So let's go ahead and head over there and do that. We'll do try out the beta. And I'll go ahead and create a new email. High five, a confirmation has been sent to you. Check your email to get started. So I went ahead and got that email. I clicked on the link that they sent me and they said, Sidwar KD, you're good to go. Get started with Plotly. And it says now, once you have signed up, head over to the settings page and write down your API and stream token. So they've got a little link here that's kind of helpful. We'll just click on that. I think we just want to generate a new key. There we go. And we've got stream tokens here. I guess we'll want to generate a token. Okay, so I assume this is the token that we need, and this is the API key that we need. So I think we'll say done. Actually, why don't we go ahead and save off this API key. Bring up Sublime Text here and say the API key is that. And the token come back here and get that. Okay. All right, we'll say done. And let's come back to the Instructable. Okay, so now I have all of this other stuff set up. I can SSH into my Pi, so I don't need to mess with that step. And it says that we need to install a bunch of things here. And a lot of this stuff up top is installing the Python development tools and the install stuff and rpi.gpio. I have all of that, so it looks like the only thing I need to install is the Plotly module. So let me slide my window over here. I'm SSH'd into my Raspberry Pi, and let's go ahead and do sudo pip install Plotly. And see what that gives us. All right, awesome. Successfully installed Plotly. So slide this aside here. And now it wants us to clone the repo from Github. So instead of doing that directly on my Raspberry Pi, I'm going to use a little Python utility that I wrote called preheat, which is kind of like a thin Dropbox client for the Raspberry Pi. So I don't want to change any of this code directly on the Raspberry Pi using Nano or Vim. I want to do it with Sublime Text on my desktop machine here. So what we'll do is I have a Git shell here that's in my Dropbox. And so we'll just go ahead and slide this down. Go ahead and copy this URL. Now it says clone the repo and they give a path to the zip file. I think we'll want to modify that to just take the raspi-plotly.git repo. So let's go ahead and give that a try. Let's go ahead and hit enter. It says it's cloning into it. All right, pulling it down, awesome. Okay, now let's just cd into that like they recommend. And let's see what we have here. Oh, just a couple files. And later on in the Instructable, it talks about this temp36.py for legacy support. So I think the file that we want to mess with here is the streaming temp36.py. So let's go ahead and slide this aside, bring up Sublime Text. And what we'll do is we'll just drag the Raspi-Plotly folder over here. So it brings it in. Okay, so now the first thing I'm going to want to do is I wrote a little library for the hardware that I used for my Skillshare class so that it was easy to access some of the functionality. So I'm going to go ahead and copy that file from my other project and paste it into the Plotly project here. You should see it show up there, hardware.py. And all this is it imports the arpi.gpio library and just has some functions for the hardware that I created that allows me to interact with it very easily, just to get a temperature from the I2c temperature sensor that I have connected. I'm not using an analog temperature sensor like he does in the Instructable and attaching it to an analog to digital converter. I'm actually using a temperature sensor that is I2C ready that I picked up from SparkFun. And so I want to just modify the code here to use that sensor instead. So we'll be using this hardware.py. Okay, so let's come back here and take a look at streaming temp 360 36.py. And the first thing I want to do is from hardware import pi hardware. Okay, so that will give us access to those functions. And we'll come down here. I don't like using the BCM mode and the GPIO library. I like referring to the pins just by their physical pin number. So I'm actually going to change this to board. That's just a preference that I have. And then let's see, we'll come down here. I don't think we need to change any of this code. This is just how we prompt for questions. This is setting up the color scheme for asking those questions. And so it asks for a few questions here. And so an additional piece of information that I'm going to want to have is a sensor type now. And so I think what we'll do is right before we ask about the temperature, let's ask about the sensor type. So I want this to be backward compatible, so it'll still work with their original example. So we'll do sensor type. And then we'll just ask, right now I'll just support the two options. So we'll say, are you using and then the two valid options here are going to be M and I. And so then right after that, I guess another thing to make this a little bit more configurable is if they do choose I2C, we'll need to know what the address of the sensor is. So why don't we go ahead and do an I2c Adder here. We'll just initialize that to none. And we'll say if sensor type equals I, then we'll want I2c Adder to be the integer output from asking the address. So instead of typing this over again, why don't we just take the delay code here? It'll be very similar to that. And then we'll say, what is the address of your sensor? And that should work. That should put that into I2c Adder. Okay, cool. Now if we keep scrolling down here, we'll probably want to leave all this code the same. The layout shouldn't need to change. So now here's the function that reads the analog to digital converter if you're using an analog temperature sensor. So we can just leave that there. Shouldn't need to touch that. And here we're setting up the SPI. Now we'll only want to do this if we're using that type of sensor. So we'll say if sensor type equals M, then we'll go ahead and do this. And we'll do an else. Well, actually we don't need an else there. We'll only do that setup if the type is M. Okay, and as we scroll down here, we've got this all looks like it could probably stay the same. It'll fill in our username and API key. The moving average can stay the same. So stream data, if we keep scrolling down here, the very last thing we do is we set data equals to stream data, which is just a loop, an infinite loop of reading the temperature and having a delay in between. So we just need to probably hijack this part to do our own temperature reading. And so we'll leave all of this in here, but we'll change this to be if sensor type equals M. And then it looks like, yeah, it looks like all of this down is pretty generic. So I think we just need to put all of this underneath of it. And for now, we'll just say else. If you wanted to extend this more, you can do an if-else to support different kind of sensor types. Maybe you have an SPI sensor that's not an analog connected to an SPI ADC, but just an SPI one. So anyway, we'll just do an else for now. And all we need to do is set temp F to hardware. Oh, actually, we haven't defined it yet. Let's come back up here to the top. Okay, right where we do this initialization, let's go ahead and create our hardware equals pi hardware. That'll just initialize all the pins for the specific hardware setup that I have. That's got an LED, it's got a display, it's got a temperature sensor. We'll just configure all that so we can have access to it. Then we'll come back down and we'll say hardware dot get temp. And that's all we have to do there. And then to translate that into temp C, I'll just do a temp F minus 32 and divide the whole thing by 1.80. And now that this temp C and temp F are under these conditionals, let's just come up here and initialize them to none. Okay. And then I think that should just flow through. It'll decide which one it's doing, do the average temperature, create a reading, and then it looks like it should just stream it to the service. So I think that is all that we need to do. So the only way to find out, I guess, is to save this and then get it over to our Raspberry Pi. Well, what I'm going to do is I'm going to bring my window back over here. And you've got a lot of folders here. I'm not sure what I did with my preheat. It might be in my Ponix here. Preheat, there we go. Okay, so let's do a copy preheat. Well, before we do that, actually, let's do a µdir. We'll just call it temp plot. And let's copy Ponix preheat to the temp plot folder here. And then we'll cd into that. Okay, I got my preheat file there. And the way this works, I don't want to go into too much detail. I'm actually still just kind of developing it. I like it for bringing files down. I didn't want to create a file share with my Raspberry Pi, and I feel like this works pretty good. It's not a lot of code. It's pretty simple. But all I have to do at this point is do a sudo Python, because it's a Python script, preheat, and then give it the name of the file that I want to bring down from my Dropbox account. It can be anywhere in my Dropbox account. And so I'm just going to type in streaming TMP36.py. And then by default right now, I think I'll change this. It's going to try and execute that after it pulls it down. But if we just do a -d, it'll just download the file. It won't do anything else. So I'm going to go ahead and do that. And if we do ls, okay, you can see it there. We'll just do a nano streaming.py. You can see it's got all my changes in it. And now I can just make changes back on my desktop, allow Dropbox to sync them, and then just run the preheat command again, and it will bring down all those changes. So I like it. It's pretty neat. Like I said, it's pretty simple. So let's clear this. So if we've done everything right, which will be a miracle if we have. So why don't we just, you know what, give it a try. Sudo python. Okay, so let's go ahead and hit enter here, see what happens. Okay, no module hardware. That makes sense. I need to pull that one down as well. It's also in my Dropbox, so I'll just do the same thing. I'll do sudo preheat. Sorry, sudo python preheat hardware.py. I'll just download that. And I'll just take, you can see I have it in two different spots. I just added this functionality in where if it finds two versions, it'll ask you which one you want. So I'll just pull the one that's in the Raspi-Plotly one. So I'll do 1. Okay, now I've got hardware.py there. Let's try to give this another run, see what happens. Okay, we'll say test temperature. My Plotly username is sudo and my API key. Well, if I come back here, do a Control-C, just right-click and it'll paste that. My stream token. Hopefully the temp part of this works, because I'm assuming I'll have to do this all again if it doesn't. Okay. Okay, here's the new prompt that I added. So I'm going to do I, and the address of my sensor is a good question. I do not remember. Oh, actually, I added that question in there, but I did not put any code to in my hardware library to support it. So it won't really matter what I enter here. I would need to modify my Pi hardware library to accept an address for setting up the sensor. It's hard coded right now, so you can get the idea here. You would enter some sort of an address and have it configure your sensor accordingly. So I'm just going to put, I don't know, 72. I don't think it matters. Hit enter. Do you want to plot Celsius or Fahrenheit? I would like to plot Fahrenheit. Scatter or bar chart? I think I'd like a bar chart, I guess. And the poll is a minimum of 1 second, so we'll say every 5 seconds should be good just for testing. Hopefully this does not crash. Let's see what happens. Okay. That does not look right, but it's doing something. It's interesting. All right, I assume to get out of this, we just do like a Control-C. Okay, so let's take a look at this URL, I guess, and see what happens. So we want to do ~sudo/0, I think is what it was. Well, there we go. 66.3. Okay, that's pretty cool. Okay, after looking this over, I'm not really sure what's going on there. It does look like it is logging data correctly. So let's give this another run and change a few of our settings here. Wonder if the guys at Plotly can let us know what's going on there. We'll post this as a comment and see what they say. Let's go ahead and Control-C out of that. And now you can see that the URL just changed to a 1. So let's come back to the test plot here, come to a 1, and see what we get this time. I assume, oh, it's mostly 66.4, but it just drops really low right there. All right, cool. I've never used Plotly before. I just saw that Instructables. I wanted to see how hard it would be to maybe modify some existing hardware that I had. As you can see, it's not really too hard. If you've got some hardware set up, in my case I had a temperature sensor that wasn't exactly what they were using, but if you just dig into the code, you can modify it a little bit, and you can get some pretty cool results. So props to the people at Plotly. That was fairly easy to set up. It's a nice little streaming example that they have there. You can use their more advanced API and create your own sort of functionality and graphs. But I think that was a cool little project. It didn't take me very long at all, and looks pretty good. So thanks for joining. Hope you found this useful, and we'll see you next time.